Now let us control the LED using a push button. Okay, so we'll take these components from this component list: a Arduino board, 2 resistors, 1 LED and 1 push button. Now I have placed it in this breadboard. So in this breadboard, normally what happens, the topmost 2 rows and the bottommost 2 rows, they are connected horizontally. That means every point in this row is connected internally. Similarly, in this row and this row, in these 4 rows, all the points are connected internally. Whereas in this part of the breadboard, the connections are connected vertically. Okay, so all these points in column number 1, 2, 3, 4, 5, in all these columns, the points here are connected vertically. Now I have already placed a LED here and a push button here. Now to connect this LED, what we have to do, at first we'll take a 5 volt from the Arduino board to the breadboard. Okay, you can change the color to red. Next we take the ground terminal from the Arduino board to this point. Okay, now the entire row where I have connected that 5 volt will have a 5 volt power, whereas in the row where I have connected the ground of the Arduino, all the points in this row will be grounded. Now this is the cathode of our LED, so this will be connected to ground. Okay, so I have connected it. So since these 2 lines are in the same horizontal line, so they are grounded. Now from this point, the other point, anode, okay, we have to use a resistor. Okay, and let us rotate the resistor. Okay, let us connect it here, and through the resistor I will connect it to pin number 12. Okay, that means this is our output. Okay, now to control this LED, I have to connect this push button also. Okay, so from one end of this push button I have connected to VCC, that is 5 volt. Okay, I'll bring the resistance. I will rotate it. Okay, from this end I will ground it, and from this end I will take it to pin number 3. You may change the color so that I have orange. Now my circuit is ready. Okay, so what I will do now, I will go to the code section. Okay, so in the code section you can see, actually this one I have already written, so I'll explain it to you. At first I have taken the pin, initialized a variable pin button as pin number 3. Why? Because at the pin number 3 we have our push button connected. Okay, so I have taken a variable pin button and taken as 3. I have taken another variable LED and given it as 12 because the LED is connected to pin number 12. Now after this initialization process, we will set up our Arduino. How? we don't know which pin will act as input, which pin will act as output. So we'll first select the mode. So while writing this instruction, pin mode, pin button is input and pin mode LED, output. That means the pin button, that is pin number 3, will act as input, and LED, that means pin number 12, will act as output. So this is about setting up our board. Now during this process, what will be done will be explained or will be written in the void loop. Okay, so here another initialization of variable is taken, like state button. This is one variable, okay, and this variable will contain whatever value is obtained in pin number 3. So digital read pin button, that means if pin button is high, it will take high value. If pin button is low, it will take low value. So it will continuously read the input over here. Okay, whatever the input, it will continuously read and assign the value to this state button. Now this state button, okay, the value of this will be checked. Okay, if it is high, equal to 1 means if it is high, that is pressed, okay, so LED will be high, because that is our ultimate goal, that when we press the push button, it should glow. Else if we release our hand, it will put off. So else digital write LED equal to low. So to read the value over pin number 3, we are taking the instruction digital read, whereas to glow this LED on or off, we have to write the instruction digital write to pin number 12, either high or low. So once our circuit is completed, our code is completed, we'll start simulation. So you see, when I will press the button, the LED is on. Once I leave it, it will be off. Once I press it, it will be on. Once I leave it, it will be off. Okay, so I have stopped the simulation. Now let us consider another concept of this coding, that is, till now when I have pressed, it was on. Once I leave my hand, it has turned off. But let it be like our switches that is available in our home. That is, once I press the switch, it has to be on, and even if I leave my hand, it will be on. Again, next time when I will press it, it will be off. Right? So for that, I have to change the code a bit. So let me change the code. Okay. Here we have taken some initial, have considered some position, like a state has been taken for LED, which is low. We don't know the previous state was low or high, but we have considered that previously, let us suppose it be low. Okay, and if we just press and leave, what will happen? It will give us a debound state. Debound state means what? Suppose in a computer keyboard, you press A for some millisecond more, what will happen? A. Various numbers will come now. So that is called debound. That means there is a particular time after which if we keep on pressing, it will be taken as new input, right? So let us take some time for debound, which is 200 millisecond. Okay, so if I press it for more than 200 millisecond, it will take as next high state. So again, I have set up pin button as input and LED as output. Now it will read the digital read, the state button. If state button is high and previous was low, and this time is greater than the debound state, then LED will be high, state LED equal to low, else state LED equal to high. So this, if you start coding for 2, 3, 4 projects, it will be understandable to you. Okay, now let us see the difference in simulation, how it will work. Okay, see, it is on. Again when I will press, it will be off. Again when I will press, it is on. Again when I will press, it is off. So this is how it will work.